If you are new to this platform, subscribe. I'll be making tons of content. Welcome to my lesson. In my lesson, we are going to talk about the system compensation as in control systems. So there are few objectives that we are supposed to achieve them at the end of this lesson. So one, we shall look at the needs for compensating the network. Number two, the second objective is to derive transfer functions for the compensating network. And then lastly is design compensating network. So as part of the introduction, we are going to look at the compensation, the definition, and we say a compensator is a control system component that regulates the operation of another system. So the main function, or what it meant by the compensator, is a control system that regulates the operations of other systems. And most of the time, this is accomplished by conditioning the system input or the output. Secondly, we are also supposed to look at the types of compensation in control system, and we have some view of them. We have the series compensations or cascaded. We have also the feedback compensations or parallel feedback. The other one, so the series compensation, this one pertains the connections between the error detector and the plant. So the error detector and the plant are in series. And there we have a block diagram where you can see the block diagram. You can see the input, the output, we have the gain, and we have the feedback. So control systems compensation technique is the adjustment to compensate for system flaws. So compensating devices can be electrical, mechanical, or hydraulic in nature. So most of the devices that are usually compensated, it could be in electrical or mechanical or hydraulic in nature. And the most common types of electrical compensator is the resistor, capacitor, filter. That is RC filter. The lead lag network is the most basic network used for the compensator. So most of the time you will be hearing the lead network and the lag network, and in some cases there are networks which combine lead and the lag network to give some certain characteristics. So the term lead network usually refers to a system with one pole and other zeros. And if we want to compensate for a dominating zero in a control system, we must use a lead compensation network. So there you can see a block diagram that represents the phase lead compensations. Phase lead compensation is composed of resistor and capacitor. Both are connected in parallel. Now, what are the advantages of lead compensations? One advantage is that it increases system speed by shifting the gain crossover frequency to a higher value. So it increases the system speed. The second advantage of the phase lead is we are saying because the phase lead compensation is present, the system maximum overshoot is reduced. So the maximum overshoot is reduced. What explains that is because of the presence of the capacitor and the resistor, and both are connected in parallel. Then what are the disadvantages of the phase lead compensations. So one, we have one which is the main, and we say steady state error is not improved. Type number 2 is phase lag compensations. Phase lag compensation. So a phase lag compensation is a system that is a combination of one denominator ball and one zero. The denominating ball is the one that is closest to the origin of the ball. So we must use a lag compensating network if we want to add a dominating ball for compensation in a control system. So in our lesson, we have seen the definition of a compensator, and we say compensator, its work is to operate or regulate the operation of another system. We were saying most of the time this is accomplished by conditioning the system. And then also we've also looked at the types of compensation in control system. And we have the series compensations, we have the feedback, comparisons, we have the state feedback, and so series compensations, I told you it is used, or this one is a system where error detector and the plants are connected together. And down you can see the block diagram of the compensator. So R input is the input, ZS is the output, GS is the gain of the system, and HS is the feedback of that system. Now then we look at also the control system compensating technique, and we say a compensating technique is one that adjusts to compensate for a system flux. So compensating devices can be electrical. So we've named where we can apply the compensations, and we can apply in electrical systems, in mechanical, and even in hydraulic nature. So another one is the phase lead compensations, and that one we are saying it is a system with one pole and one dominating zero. Down there you can see the phase lead, and the phase lead has got the capacitor and the resistor connected in parallel. Now the advantages of the LED, we say it increases the system speed by shifting the gain crossover frequency to a higher value. We say because phase lead compensation is present, the system's maximum overshoot is reduced. We have one main disadvantage of the phase lead compensation, and we say the steady state error is not improved. And lastly is the phase lag. And the phase lag, we are saying this is a system that has a combination of dominating pole and one zero. So that is the end of our lesson, and I told you what we are going to look at this lesson is how do we compensate for a system. So when we talk about the LED, LED has got a resistor and a capacitor connected in parallel. And then we're also asking ourselves why is compensation so important, and we say it is important because it regulates the operations of another system. I say most of the time this is accomplished by conditioning the system input or output. And we also told you the types of the control system. I told you there is what you are calling it the 3 categories lag, the 3 categories LED, and the lead lag network. So number 3 is the combinations of the lead and lag network. I think with that, say thanks for your cooperations, thanks for your participations, and waiting to see you in the later lessons. Thank you and goodbye.